in case people find it very useful. Okay, I'm waiting for the recording button to pop up. Hang on. Okay, Ken, Koi, yeah. Are you able to, let us know? Yeah.
Yeah, I just want to ask, so you are saying that velocity magnitude is 4r at all points. It means that it is 4r for that particular streamline, right? So if you were to scroll up to the diagram, right, since the two locations, I assume is along the same streamline, right? Because it's like stick to the curve, right? So it belongs to the same streamline. That's why the magnitude of the velocity is the same, right?
Yes.
I mean, for r, right?
4r. So 4r is only for that particular streamline.
Okay, okay.
Wait. Let me see. Let me be very sure. Huh? Okay, I will say this. We have to troubleshoot. Okay, I apologize if I sort of like forgot parts of it because this was what last week's stuff, or even earlier, I think. Okay, let's see the genesis of V. In this case, V, as I mentioned earlier, we have took V as square root of VR squared plus V theta. Okay, so let's start from there. What is our VR and V theta that we use to get 4R? So let's backtrack a little bit to go to V to see how we get our VR and V theta and see whether the VR and V theta, were they expressed in general terms, that means valid for the entire flow field, or is it valid for just the streamline? Okay, so I think you asked exactly the right question. Okay, so let's go back. Okay, now, so if you think about it, okay, so this slide shows how we get the VR and V theta. All right, so VR, okay, it was obtained by doing this partial differentiation of the stream function, correct, psi? Okay, now this stream function, psi, okay, actually describes, if you look at the blue streamlines in the figure, actually this psi, all right, actually describes the entire flow field where R is in meters. They never say that in this case, R is along the wall exactly. Okay, so it's in fact valid for all flow within the flow, plus the line that describes the wall. Remember, all right? Okay, because that's the genesis. That's part of the potential flow theory, right? Okay, so now if you take a look at V theta, once again, it's derived as a partial differential of the stream function. Okay, and this stream function once again refers back to the general stream function. So in this case, okay, the stream function, okay, so in this case, all right, this V velocity magnitude actually describes the velocity, all right, everywhere, all right, rather than just along the wall. Okay, so yeah, so this works out everywhere. So that means, right, if let's say I want to find out the velocity magnitude at, let's say, coordinate 1, 1, okay, then I have to find out what's R associated with 1, 1, which will be square root of 2, correct? Then the velocity there will be 4 times square root of 2. Okay, so I'm not too sure, man. Does that help? Does that answer your question? Thank you very much. Okay, you're most welcome. Yeah. Okay. Yeah. Okay. So I think yeah, keep this question coming. I like this kind of question where we talk because I think this is something that's quite lacking nowadays. All right. Okay. Okay, maybe I should clarify another thing as well. Since it's recorded, I might as well just record it so that everyone can go back and take a look, take a listen, if you will. Okay, one thing is, you know, there are people who ask me, okay, for potential flow theory, it seems like we never really take into account potential flow energy. Not potential flow energy. The potential, the gravitational potential here. Okay, why is that the case? Okay, my answer to that will be for some of the, okay, let me maybe just pop a question. Like let's say this one. Okay, all right. As you can see over here, I did not include any Z term. Do you guys realize that? Okay, okay. The rationale is, all right, in this case, we're talking about something that is very, very small, 40 mm, 50 mm. Okay, you will still be perfectly fine if you were to incorporate the z term here. That means, let's say rho naught plus half rho v naught squared plus z naught, let's say. All right. And then over here, you have another z term. That's perfectly fine. Okay. But in this case, all right, based on the engineering appreciation, all right, the dimensions we are looking at are very, very small. Very, very small. It will hardly affect the answer that much if you think about it. So in this case, all right, I decided not to include them. But probably what I should have done over here is to include a statement, all right, that says, assuming that the height differences, all right, are very, very small, such that any gravitational potential hit can be ignored. And then before I begin to use this, then I think it'll be a lot more clear. Okay, all right. All right. Now, things will not do, of course. I mean, we cannot ignore the height term, if let's say, right? Later on, as you guys encounter in an unsteady flow, when let's say we're looking at the reservoir, okay, whereby the water surface height is at like 50 meters, 20 meters, then of course, then in that case, all right, the impact of not including the height term, right, okay, will be tremendous. Then in that case, surely we need to make use of the height term. Okay, but for small little things like 40 mm cylinder, 50 mm distance, then we can ignore it. Okay, now, of course, I'm quite sure the question that's on a lot of people's mind is that, so what will happen if I include it? What will happen if I don't include it? Okay, I accept both. Okay, I accept both. Okay, but maybe you should have a sentence that say that, oh, since the dimensions that we're dealing here is small and unlikely to have an appreciable effect on the gravitational potential hit, okay, then the height difference are ignored in the following calculations. Okay, that is perfectly fine with me. Perfectly fine with me, because I think for something that you know, for a term whereby its contribution is going to be so small, if you think about it, I don't want you guys to waste your time calculating something that probably only contributes a tiny fraction to the overall answer. Okay, I prefer to be more practical along this front. Okay, it's a bit like, you know, I think I'm not too sure whether it was one of you or one of the full-time students that asked me, you know, whether we need to interpolate for values. Let's say I think he or she asked the question, you know, let's say, you know, if they were given a table and then they need to find out the density of a certain fluid, all right, at a certain temperature, but you know, only values associated with a higher and a lower temperatures are given. Right, does he or she need to interpolate? Okay, so my answer was that, all right, it depends on whether you have time. Ideally, you should interpolate. Okay, let's say you have the density at, let's say, temperature 25 degrees, and then you have the value of the density at temperature 30 degrees, but you need to find out the density at 27.5 degrees, okay, or 28 degrees. My answer to this is very simple. If you have got time, you're confident that you're able to do it fast, okay, yes, do it, okay. But if let's say you have no time, okay, what you can do is, okay, just take the value that's closest to the temperature, right? Okay, so let's say you wanted to find out, if you were to interpolate, you will have to interpolate for 27.5 degrees, let's say, okay? But let's say you have no time, just pick the one that's closest, let's say 30 degrees, okay? And just write something on the paper, say that, all right, due to time constraints, I will assume that the density, all right, that of 30 degrees Celsius, okay? All right, that's fine, okay, that's fine. Okay, I may dock off 1 mark for the lack of integration, but if you think about it, 1 mark is not too great a sacrifice if you have not much time. Okay, so I hope I clarified that as well. Okay, good. I love questions like this. Please, please let me know. Okay, so thanks very much, Corey, for the question. I hope the others also sort of like, you know, get something clarified with the question as well. Okay. Right. Oh, I forgot something. Later on, I will put up an announcement with respect to what one of your kind classmates have decided to do. So he was emailing me today regarding how to solve one of the tutorial questions, like, how is it possible that we sort of like manipulate the differential equations? Okay, how do we so-called quote unquote see it? Is there a more systematic way? Okay, so I think he and his friends worked out something. All right, I need to applaud him and his friends for doing that. So after I think he asked me whether it's okay for him to share with you guys. And of course, right? I think that's a fantastic idea. So what I'm going to do is, and I've sought his agreement. What I'm going to do is I think he provided me with a picture of the more systematic way. If you can't see the relationship, I'll post it on the contents page of this module in NTU Learn, and then I'll put in an announcement so that you guys can go in and take a look for yourself. So I would like to thank, geez, I forgot the name, Cornelius, I believe. I hope I did not massacre the name. Yeah, Cornelius. All right, so Cornelius Tong, I think. Thank you very much for willing to share this with the rest of the classmates. Okay, if you guys who are here who knows who Cornelius is, please thank him. Okay, all right, I think that's very, very generous and nice of him. Okay, okay, all right. Are there any more questions before I stop recording? Because if there are questions, I'll just keep the recording going. Yeah. All right. I believe one full-time student asked me with the extension of the stabilization phase, are we still going to have like in-person CA or online CA? Okay. Any one of you got the same query? Does anyone of you guys have the same question? Hi, who's this? Hi, who's this? I can't catch you. You're breaking up. Anyone want to ask me anything about that? Please unmute yourself. Who's this? May I know?
This is Junjing. You can call me
Oh,
Tina.
Junjing. Hi.
Yes, hello. Hi, Prof. I remember the announcement says we need to go to lecture LT20 next week, is it?
Yes, on the 28th.
Okay. 7:30.
7:30. Yeah, I mean, I give you guys extra 30 minutes to get to the campus. Or do you guys need more time?
For me, it's okay. I think
Okay.
one we also had in the lecture hall. Yeah, 7:30, same.
Okay.
Yeah.
So so this one goes up to Junjing, you and of course all the other people here, is that I'm still waiting for NTU's advisory, okay, at this point. Because according to the last advisory, okay, we are allowed to go for classes and assessments, okay, before 24th October, okay? So long we keep it to less than 50 in the LT and so on and so forth, okay? Now I'm not too sure whether this extension, all right, will cause NTU to tighten up the safety measures. I hope not, because I'm quite sure you guys agree with me, right? Having an online CA is very, very awkward. It's very, very awkward. Okay, and yeah, so let's keep our fingers crossed. In fact, let me see whether I can pull up the NTU's advisory. Okay, so let's take a look together. Yeah, but that's based on what I've heard previously. Okay, Ken. Let me see, yeah. Let me unshare the PowerPoint and share this one. Okay. So I hope you guys can see the email that I received. Let me just zoom in a little bit more. Okay, so this is the current extension. These are the rules for the current extension, for the current stabilization phase. So as you can see, right, Okay, we've got all these restrictions. Right? Don't worry about workplace or dining. I don't think you guys will be doing that. But let's scroll down. Yeah, I think this is something that we have to take note. Examinations and assessments will continue in zones of up to 50 people. So even though lessons will be moved online, it is okay for us to go for in-person examinations and assessments, so long we have no more than 50 people in a particular zone. So we consider LT as a zone, okay? And I believe for this particular cohort, there's only so many people, right? There's not only 30-something people, yeah? So I think it should be fine. Does anyone has got anything to say with respect to in-person CA? Anyone who is like, you know, under HRW, health risk warning or health risk alert, and things like that? I'm not too sure, you know. You guys have to let me know if let's say, for example, you guys are having difficulties, things like that. Okay. Yeah. Okay. So thanks very much, Jinjing, for your question. I think at this point, CA will proceed as in-person CA. Okay. If let's say the rules indicated in the email for the current extension, for the current stabilization phase, do not change. Okay. Right. So thanks very much. Okay. And yeah. Yes. Does anyone have any more questions? Please let me know. I think it's a nice time to. It's a good chance for us to get our expectations right, coordinate some of the things together. I always think that students should have a stake in deciding how they want to be taught and how the lecture should be delivered to a certain extent.
Thanks, Prof. For the C2, we can bring one A4 paper allowed, right?
Yes.
Then for the exam, we cannot bring anything with it.
Yeah. So what happened was that Prof. Tuan and I consulted the school, and the school says that right, it should be a closed book, right, for this module, because of the. Have you guys heard about the OBTL, outcome-based teaching and learning? All right. So according to OBTL, it has got to be a closed book. Yeah, unfortunately. Yeah. Okay.
Oh, okay. We
Don't be
prefer
too
A4,
sad.
but yes. Okay.
Yeah.
All right. Thanks.
But maybe I'll just say this, you know. So usually what happens is, I think students should fear open book assessments. Because if it's open book, right, that means we cannot test you things that are so-called straight from the material that you guys have. So a closed book examination sometimes is good news. Sometimes, I'm not saying all the time, but sometimes it's good news. Okay. Yeah, I don't know whether that comforts you or not. I hope it does. Yeah, I hope it does. Yeah. So, okay. I'm trying to take a look at the results of the survey that I asked you guys to do previously about whether should we go for, you know, should we go for online, you know, basically doing what we're doing now. That means I record the videos, you guys look, and then we, you know, come together on every Thursday for the Q&A session, or whether you guys want to go back for in person, because actually it is possible, because there's only so many of you, not too many of you, 30-something of you. It is possible for us to go to in-person teaching. Does anyone has anything to say about this? Or you guys just let me decide? Oh no, I'm not too sure. Yeah, what is what? Which is that you guys prefer? Yeah, but do let me know Let me see if I can download the survey outcome. Okay, in the meantime, please think about any questions that you guys want to clarify with me, because I think keep this up. Okay, just keep this up. Okay, I'll stop the recording. Right, if you're not too, some people told me that they are not too comfortable to ask questions, too many things when they are being recorded. I'll just stop the recording.